I'm Vijay Kumar. Now we are going to discuss about the feedback effects in control systems. So that effects to be observed on gain, stability, sensitivity, and the external noise disturbance. First one, gain. As we know that the control systems are classified into open loop. So open loop is like this. We have a plant, the reference input R of t and the controlled output C of t. In between we have an open loop gain of G. Okay. So for an open loop system, its gain is G. Whereas if we consider a closed loop control system, the closed loop is formed by like this. We have a plant G and that output C, the controlled output C is given back to input through a feedback connection. Let us assume that feedback connection gain is H. Then it is given to an error detector. So the error detector detects the difference between the reference input and the feedback output and gives us an input for the plant. So this is error detector. So this is what a closed loop control system. Now here in this case the transfer function is t equal to g by 1 plus or minus gh. If a positive feedback we consider the gain is g by 1 minus gh. If we consider a negative feedback then it will be g by 1 plus gh. So if we look at a gain point of view, for an open loop control system the gain is g, whereas in a closed loop control system the gain is g by 1 plus or minus gh. So there is a variation in gain with respect to the open loop gain. It is g by some quantity. This quantity is happened due to the feedback connection. Due to this feedback connection we have g by plus or minus this 1 plus or minus gh. So with the feedback the gain will vary. So this is what the effect of feedback on parameter gain. So next if we consider another one, stability. Stability means everyone get a picture of bounded input, bounded output. So for a bounded input we expect a bounded output. So since we don't have any feedback connection in open loop system, there is no problem with respect to stability in open loop. No problem with stability. Whereas as we know that in a closed loop system, due to the existence of feedback which makes an oscillatory response. So this oscillatory response obviously provides a stability problem. G by 1 plus or minus GH. If this GH quantity, it may be there is a chance to get plus or minus 1, then the whole denominator quantity will be leads to 0. So 0 means a gain of infinity we will get. So an uncontrolled output. So this uncontrolled output provides instability. So in a closed loop control system there is a problem with stability. Whereas due to non-existence of feedback in open loop there is no problem with stability. In the next factor, sensitivity. So sensitivity being defined as dou t by dou g by g. It is a percentage change in the total transfer function with respect to the percentage change in the gain. So this can be rewritten as dou t by dou g into g by t. So for an open loop, t equal to g, then s is equal to dou by dou g of g into g by t. G by t is g. So it gets cancelled. Dou g by g is 1. So sensitivity is equal to 1. Whereas in closed loop, t equal to, as we know that 1 by, let us consider a negative feedback. So g by 1 plus gh. So t equal to g by 1 plus gh, then dou t by dou g is equal to, differentiate it with respect to g. So it is of u by v rule. So 1 plus gh with respect to g, it is 1 minus g into 1. It is 1 plus, sorry, it is 0 plus, it is h by 1 plus gh whole square. So it is 1 plus gh minus gh by 1 plus gh whole square. Gh cancelled out. We will get 1 by gh square. Then what about g by t? The factor g by t equal to g by t is g by 1 plus gh. So gg gets cancelled out. We will get 1 plus gh. Now the sensitivity is, sensitivity s is equal to dou t by dou g, which is equal to 1 by 1 plus gh whole square multiplied with 1 plus gh. So both gets cancelled. We will get 1 by 1 plus gh. So if you observe here, for an open loop, the sensitivity is 1. Here the sensitivity is 1 by 1 plus gh. So due to the existence of feedback, there is a sensitivity of 1 by 1 plus gh. So there is a sensitivity is low. The next parameter is on noise, external disturbance, noise. If we consider an open loop system, it has been like this. Let us say this is some G1, and here if there is a chance to get any noise, so this is noise, this is the reference input, and here let us say if we get another plant gain of G2, then this is the control output. So the total gain T equal to, without the presence of noise, it is equal to G1 G2. With the presence of noise, it is equal to G2, whereas this is in open loop. In closed loop, you can modify the circuit like this. The plant gains are distributed like this, G1 G2, like we consider in open loop. Here there is a chance to get noise. It is like this. So here comes the noise, and this is an error detected. This has been given to H. So like this. This is the control output, and this is the reference input. Consider a negative feedback only. So without noise, the gain is G1 G2 by 1 plus G1 G2 H, whereas with noise the gain is, so whenever we consider noise, the reference input becomes 0. So since it is a transfer function model analysis, it is a single input single output analysis. So we'll consider a single input only. So the transfer function will be, the noise transfer function will be it is G2 by 1 plus G1 G2 GH. So if we consider the gains without noise with respect to the gains with noise, the gain is low. So that noise feedbacks makes a noise to be low. The noise, it can suppress a noise, a low gain we will get. Okay. So thank you.